Hey everybody, and welcome to exercise 1. This is on page 24 of the workbook. And this is an exercise in thinking about relationships between vectors in the context of dot and cross products. This is going to ask us a number of questions, and more often than not, the cross or the dot product is going to be involved in answering the questions. Okay, so let's read this together. So they're giving us two vectors, v and w. V is 3i plus 3j plus 4k, and w is 3i plus 4k. And part A is asking us to find the measure of the angle between v and w. Okay, how do we do that? Well, let's think back. And we've talked about a number of different topics and formulas, and is there a formula that would allow us to get our hands on the angle between two vectors? Okay, and I want to scroll back and just point you to kind of the only formula I think we've had that involves an angle, and that's this one here on page 22, the geometric definition of the dot product. Anytime you want an angle between vectors, that's probably the one that you want to go to. All right, so let's try that out here. So I'm just going to start by copying down that formula. It says that v dot w is the length of v times the length of w times the cosine of the angle in between. Okay, so we need to do some calculations to use this. On the left-hand side of the formula, we need to calculate v dot w. All right, so we're going to take v and dot it with w, so let's see. That's going to give us 3 times 3. That's the product of the first two components, plus 3 times 0, because notice that w has no j component, plus 4 times 4. Okay, all of those together are the dot product. Okay, and then the lengths, let's see, we may run out of room here. So the length of v is going to be the square root of 3 squared plus 3 squared plus 4 squared. Okay, and then the length of w is going to be the square root of 3 squared plus 4 squared. Okay, sorry to write so small on you here, times the cosine of the angle. Okay, and let's actually do the calculations there. So starting with the left-hand side, 3 times 3 is 9 plus 16. That's going to give us a 25. And over on the right-hand side, if we do the calculations under those square roots, we're going to get the square root of 34 for the first one, and then the square root of 25 for the second one, times cosine of theta. And remember, what we're looking for is the angle between the vectors. We want to find theta. Okay, so we're trying to solve this equation for theta. So let's see, if we divide both sides by, well, let's see, we might notice that the square root of 25 is just 5. Okay, so if we go ahead and divide both sides by the two numbers that you see on the right, square root of 34 and 5, we're going to get cosine of theta by itself on the right-hand side. And we'd like to find the angle theta. So how do you solve for theta in an equation like this? Well, we need to get rid of the cosine function, so we're going to undo the cosine function by taking the inverse cosine of both sides. Okay, so theta is going to be the inverse cosine of 25 over the square root of 34 times 5. Okay, and that's a job for your calculator. Okay, and if you punch that into your calculator, depending on whether you're in degrees or radians, you're going to get 0.5404 if you're in radians. Okay, and that's an okay way to write your answer. Or you could express your answer in degrees. Okay, in degrees, that's about 31 degrees if we round to the nearest degree. Okay, so there's the angle between our two vectors. Okay, and moving on then to part B here. We'd like to find a unit vector that's perpendicular to both v and w. Okay, an entirely new question here. All right, so let's start with just the perpendicular to both v and w part. How do we do that? What is a way that we can find a third vector that's perpendicular to two given vectors? And if you look back through the section, you'll notice that the cross product, that was the way to find a vector that's perpendicular to two vectors. So we're going to start our calculation by just taking v cross w. That should produce a vector that's perpendicular. Okay, so a cross product involves a determinant. So let's see, first row is going to be v, and we sneak a peek. V looked like 3i plus 3j plus 4k. Okay, w was 3i plus 0j plus 4k. Okay, we need to calculate that determinant and see what we get. All right, so starting with the I component, we are going to get 3 times 4 minus 4 times 0. That's going to be 12 minus 0i. And then the j component's going to have a minus sign associated with it. Okay, and if we cross out the row and the column that are in the j, we're going to be taking 3 times 4 minus 4 times 3. That's 12 minus 12. Okay, and then finally we come to k. We're going to have a plus sign associated with that. Okay, and then let's see, if we cross out the row and the column that the k are in, we're going to get 3 times 0 minus 3 times 3. That's 0 minus 9. K. Okay, do the arithmetic, and that turns into 12i minus 0j minus 9k. Okay, so what do we have so far? Well, that's a vector that's perpendicular to both v and w. That's really what a cross product means. Okay, is that our answer, though? Not quite, because we wanted it to be a unit vector. Okay, what was a unit vector again? Okay, well, a unit vector is just a vector that has length 1. And you can look at this vector and see that it doesn't have the right length. 12i minus 9k, that's too long. It's not a unit vector. So we need to adjust the length of this vector. So how do we shrink it without changing its direction so that it's a unit vector? We talked about this, I think it was the last section, sometime recently. We can just take this vector and divide it by its length to turn it into a unit vector. So to get a unit vector, we'll just divide by the length of the vector. Okay, so v cross w divided by the length of v cross w is going to be the calculation that we just made, 12i minus 9k, and we're just going to divide that by the length. Okay, so that's going to be the square root of the sum of the squares of the components, square root of 12 squared plus negative 9 squared. Okay, so let's see. You can double check my calculations and confirm that if you take the square root of 12 squared plus negative 9 squared, you're going to wind up with 15. Okay, and so break that up into its two components. We're going to get 12 fifteenths I minus 9 fifteenths j, k. That would be an okay answer, but you might notice that we can reduce those fractions a little bit. Okay, so we'll write that as 4/5 minus 3/5. That's a little bit simpler of a way. Okay, that should be our answer. That's going to be a vector perpendicular to both v and w, and it's going to have length 1. It's a unit vector. Okay, so we got one more part to go here. So let's take a look at part C. So they'd like us to find a value of t for which the vector ti plus 2tj plus 3k is perpendicular to v. Okay, so now we've got two vectors involved, and we'd like to do something that guarantees that they're perpendicular to each other. Okay, so what is a simple test for determining when two vectors are perpendicular? You might remember that we mentioned that two vectors are perpendicular if their dot product is 0. So a nice quick way of answering this question is to just say that what we'd like is for the dot product of these two vectors to be 0. That will guarantee that they're perpendicular. Okay, and let's see, what was v again? I need to sneak a peek here. V was 3i plus 3j plus 4k. Okay, so if that statement's true, we're going to get perpendicular vectors. So let's do the calculation. It's going to give us a way to solve for t. So if we actually take this dot product, we're going to multiply the coordinates. So starting with t times 3, that'll give us a 3t, and then 2t times 3, that's a 6t. And then finally, 3 times 4 is 12. That has to be 0. And that gives us an equation that we can solve. So put the t's together, we're going to get 9t plus 12 is 0. And then just continue. Subtract 12 from both sides. Divide through by 9. Okay, we get t as negative 12 over 9, which simplifies to negative 4 over 3. And so there's our answer. If t is negative 4/3, then these two vectors are going to be perpendicular to each other.